Ready to move on. Okay, this is 3-1. Pause if you want to see this heading. We read through these objectives. Pause if you want to see the objectives. This is exponential functions. Pause if you want to write that heading. We just read over this handout and we just wrote the definition of exponential functions. I'll read it. If you need to pause there, you can, and then you'll be caught up with us as we go through. So the definition of an exponential function f with a base a is denoted by f of x equals a to the x, where a has to be greater than 0 and a does not equal 1 and x is any real number. So that's kind of what we're looking at as we go through. I'm going to go through the next slide. The base a equals 1 is excluded because it would be 1 to the x. No matter what x would be, it would always be equal to 1. And if you've evaluated a to the x for an integer or rational numbers, for example, you know 4 to the third is 64, 4 to the 1/2 is 2, and so that's just a reminder. On your calculator, you can do 4 caret, and if you have the older version of software, you would go to 1/2. If you have a newer version of software, you would go 4 caret, and then it gives you kind of that little box, I think, and you would type 1/2, and then you have to arrow once to get out of that little box, or that little exponentiation of that, so that you're aware of that. Also, just a reminder, this is the square root of 4, which is equal to 2. So just some things to remember that you've gone over before. The next thing is now we can have things like a raised to the square root of 2 power. And so this is irrational. That means that it's not terminating, doesn't stop, and non-repeating. It doesn't have a pattern of repeated digits. So if we want to think about that, and we're getting closer and closer in our heads to the concepts in calculus. So when we're looking at something at this level of math, we want to think of this as a sequence, which is a bunch of things, you know, terms, numbers lined up, and they're in a pattern. And this is a to the 1.4, so it's kind of this rounded to the nearest tenth. Then the next term is a to the 1.41, a to the 1.414, and be careful because it kind of looks like it's repeating in these first couple digits, but it is truly not. Then a to the 1.142, and just kind of going on. And if we had a value for a and we kind of put those in, these would have a limit of some number value. So they would get closer and closer to some value, but keep in mind, because this is non-terminating, it would go on forever as we look at that. So you're going to use a calculator, and you know you can't use a graphing calculator, but your other one probably works just fine, and you're just going to evaluate these functions. And I'll give you a moment to do that, and I will tell you, maybe I'm going to just show you my answers. They have many decimal places. It looks like 2, 4, 5, 2, 4, 6, 7 decimal places. So just take a minute. You might want to write these down as well so that you know what you're doing. F of x is 2 to the x, and x is negative 3.1. F of x is 2 to the negative x, and x is pi. And f of x is 0.6 raised to the x, and x is 3 halves. And then I'm actually going to just add an extra little thing here, that this is then f of negative 3.1, which is 2 to the negative 3.1. And this is f of pi. And you are going to want to use that pi key, which is 2 to the negative pi. And this is f of 3 halves, which is 0.6 raised to the 3 halves power. So take a minute. Really, it is a good idea to type these in your calculator and see what you get. is a good moment to validate that you can do these correctly. Do you want me just to put the answers up there right now so that you know what they are and you're validating if you have them correct or not? There they are. Right now we're just making sure we can do it, so the display that's given here is just 7 places or whatever. Okay, the next thing you're going to do is look at graphs of exponential functions, and we will do that in our next one. We're actually going to graph these two and those two, so you will need graph paper. I know, I'm done. Okay.